Welcome everyone to the Widgets dev meeting. We have a talk by Don Jayamanne about the Widgets implementation in VS Code. Don?
Yes. Okay, so I will share my screen right now. Just a minute. Okay, entire screen. Hope everyone's getting this. Okay. Most of what I'm going to be talking about will be covered on this wiki. So the link is just up here. It's basically, there you go. Oh, that's the wiki where we describe a very high-level architecture of how we have implemented iframe and just some diagrams. So I will go through that today along with some diagrams. So just bear with me a minute. Okay, so the architecture I'll just describe very briefly before I just dig into a few details. We use one of the sample projects that the Jupyter community has created, iframe widgets. This is called the web. There's a Web3 repo for hosting iframe widgets in an external context. So that was the basis for hosting iframe widgets in VS Code. And so basically, there is a repo called VS Code Jupyter iframe widget. So if you look at that one, that repo is based on this one, and there is a README file in there with which details where this code is, where it came from, and what are the changes that we have made. So primarily, this one was served the baseline for hosting the widgets outside of Jupyter notebooks and inside of VS Code. We use the widget manager from Jupyter Lab. I'll go through the details later. So we have a kernel in the UI layer. So on the diagram on the right-hand side, what we have is we have the extension, which is running in a node process on the desktop. And then we have the UI, which is in a renderer. So think of that as the browser. So what we do is we have Jupyter Notebook. So think of it as, Jupyter Lab or Jupyter Notebook component that you have in the Jupyter Notebook application. Then there is a kernel, which is the kernel component. We use the Jupyter Lab kernel component from the Jupyter Lab services NPM package. There is something that looks like a WebSocket. Jupyter Lab expects a WebSocket connection. What we do is we give it a class that makes it think that it's dealing with WebSocket. And on the UI side, we have a widget manager, and as I mentioned, it is the Jupyter Lab widget manager. There is the Jupyter Lab kernel. So we have two kernels on either side, and for all intents and purposes, they're both identical. And there is a proxy WebSocket on the UI side as well. So all the widgets and everything gets rendered on the UI side. So as I mentioned,
quick question, Don. This dividing this dotted line, is that an iframe boundary, or how should I think about that?
It's a process boundary. It's a process boundary. So because the UI is in the browser and the extension is, think of it as it's the node process. So it's the extension host. So they're two completely different processes. It's kind of like think of it as Jupyter notebooks, where you've got the server component is on the right-hand side. And
okay, yeah, makes sense. Thanks.
Makes sense. So to get things working, as I mentioned, we have a kernel on either side. We try to synchronize the messages. So I'll go through it into that a little bit more in detail. We bundle the base widgets in JS file. So all the base widgets are available out of the box. The UI layer is sandbox. It runs in a sandbox environment. And we have a single iframe where we host all of the outputs. We don't have individual iframes for individual outputs. So it's one single iframe that's used. And third-party widgets are loaded from first CDN. If we can't find it from the CDN, we try to source it from the local file system, trying to find out where iframe widgets are installed from the Python environment, and then get it from there. And if they're dealing with a remote Jupyter server, we try to get it from the remote Jupyter environment. So as I mentioned, just going through the legend, widget manager, that's the Jupyter Lab widget manager. So that's from the Jupyter Widgets NPM package, Jupyter Lab. Then the kernel that I'm in green is the kernel iKernel connection. So that's the interface to the kernel. And the yellow thing is the WebSocket. So we call it the proxy WebSocket because it's not really a WebSocket. So the way VS Code works is we spawn the kernels and communicate with them over ZMQ. And so we have a ZMQ connection. What we then do is we Jupyter Lab expects a Jupyter Lab services expects a class. So they have a setting object that has a reference to the WebSocket class. So fortunately, that was really done well. So all we do is we give it a custom class that handles communication over ZMQ. So the NPM package just thinks that it's dealing with a WebSocket connection, and yeah, things work very well from there. So that's why it's called a proxy WebSocket, because it's not really a WebSocket. And all of the communication is serialized using the interact messaging package. So we just use the encode and decode methods found in the interact messaging package. Okay, so now I'll just go over the architecture in detail. So as I mentioned,
can I ask another question, Don?
Oh, sorry. Please feel free to do so.
So the kernel iConnection, the Jupyter Lab kernel iConnection package also has serialization, deserialization for messages, but you can also send the raw messages. Is that what you're doing? You're encoding and decoding using the interact package,
Yes,
and then sending raw messages back and forth?
Yes, okay. That is correct. So
we
do use the encode and decode from Jupyter Lab as well. That is correct.
Are you using the interact encode and decode?
Oh, sorry. The interact is used for the raw messages. Sorry. Yes.
Is there a reason why you aren't using the iKernel connection?
Sorry?
Is there a reason why you aren't using the Jupyter Lab serialization code?
So Jupyter Lab serialization, I think that only works at the JSON level. I don't think it works for at the ZMQ level. If it does, I haven't seen that.
Yeah.
I'd have to have a look.
There was some discussion about making them the same, right? Adding another protocol for the WebSocket to make them much more similar in structure. But that's the current state. You need the JSON for the Jupyter Lab, right? So it makes sense.
That's great.
That's true. The iKernel connection is assuming you're talking to the Jupyter server, and it's all JSON or binary messages, yes, but it's not the same as the ZMQ messages. And there's a translation that typically happens at the Jupyter server. So, okay, so since you don't have the Jupyter server, you're just encoding directly to the ZMQ message.
Yes,
got it.
That is correct. So the way, as I mentioned, on the left-hand side is the UI or the browser. So we've taken the sample project that, which one was that? The Web3 repo to host widgets. What we do is we have a widget manager. We use the Jupyter Lab widget manager, and we give it a real kernel. We give it this Jupyter Lab. So there's an iKernel connection. And so whenever so on the right-hand side is where we actually start the real kernel. So we try to keep the messages in sync so that all of the widget state or the widget manager state is as expected, because then for all intents and purposes, the kernel on the left-hand side or the browser is a real kernel. You can actually call any methods like create com connections, execute requests, get the responses, listen to IOPub messages. So we figured if we did that, then the widget manager we wouldn't have to do anything to manage any state, because then the widget manager would manage everything for us. And that's exactly what we're doing today, and it seems to work very well. So the only complication is we need to ensure that the messages are in sync. Once that's done, we load widgets using the widget manager has a hook to load widgets called the I think it's load class. So whenever a model needs to be loaded, a widget needs to be loaded, we hook into that and figure out whether it's a built-in widget. If it's a built-in widget, as I mentioned, we just bundle that and then we provide the source for that, since it's all what do you call AMD. And whereas if it's third-party widgets, we try to fetch it and provide, or we register it in require.js, and things work from there on. So yeah, that's basically it. So I think I've covered loading third-party widgets. So we try to get it from JS deliver and unpackage. And if that fails, we get it from the Python environment. We try to figure out where it is and load the NB extensions index.js file. That's assuming things work. Sometimes we found that even those files can pull in certain dependencies like Jupyter notebooks, and things might not work. So here we go. We've got a workflow on how the widgets, the sources are fetched, and we provide it to the widget manager. So in the case, we try to get it from CDN, then we fall back to fetching it from the local Python environment. So that's a very high-level overview, and that pretty much covers how we do things. I mean, yes, there's quite a lot involved. I think the most complicated bit is keeping the messages in sync. I would say it's complicated because of the hooks. So if anyone's dealt with kernel message hooks, then you would know what I'm referring to. Basically, you can have hooks, and until those hooks have been handled, you can't send or receive additional messages. So we need to ensure that at the other end, which is the node process over there too, we do not handle the other messages until the hook has completed processing.
Is that for like output widgets?
Yes, exactly right. That was for output widgets, and I think that it was the most complicated one. We found that there's a lot of special casing we had to do, and we found that there's yet one more that we need to handle. We had a user file a bug a few weeks ago with the output widgets, where you can create a custom COM message and have output rendered in that particular, in that same output as well. So that's something we're not handling today. But yes.
I still think that would have been better done on the kernel side, Jason.
We tried for a while on that, and then there's a trade-off. Where do you want your complexity? And we decided that there were less front ends than kernels, and so we're going to push the complexity to the front end. But yes, I agree. It could go both ways, and I'm happy to have that conversation. Happy to reevaluate even. Maybe at a different time.
Okay, so that was it from my end.
Yeah. Any questions for Don?
I'm curious about, I mean, the running the full kernel in the, I guess in the UI, which is sort of untrusted from VS Code. Are there any concerns about that, or other than the complexity?
The concern is, one is we do not load any untrusted code. So for instance, when we load any JavaScript files, we ask the user whether they want to enable that or not, because it's not trusted. We're bringing it from the CDN and we have no idea, even loading from the file system. So basically, we ask the user if that's something they want to allow. If they do allow that, at that point, we've basically relinquished control, because we have no control over the JavaScript that's loaded. And the JavaScript can only access the kernel through the widget manager. So there is no public property where we expose the Jupyter, the kernel. I think in Jupyter notebooks there was or probably still is a property on the window on the global object to expose it as a public property. We do not do that. simply because then anyone can write any JS code and access that. So fortunately, Jupyter Lab does have a structured way. If you have a widget, you can access the COM and you can send messages back and forth. So we rely on widgets to use that rather than exposing public properties. So there too, the surface area is reduced, and it is a sandboxed environment. So there's that too. Yeah, that's basically it. Yes.
You mentioned, Dom, that you have everything in one iframe, right? Every IPy widget is on one iframe. How do you display IPy widgets then in a VS Code notebook?
So basically, as can't remember who mentioned, they were using Virtuoso. So what we do is, I don't have a diagram for this. Let me open. Do I have a notebook that I can just a minute? I know this isn't the best one. What we do is, if you can see, can you see my screen?
Yeah.
Can you see that I'm sharing VS Code at this moment?
Yeah, I can see the notebook.
Okay. So we've got a notebook. So what we do is we have a notebook over here. Right now we've got cells. If there is an output, what happens is we load an iframe as well. So the iframe is not part of the editor. So we try to have a separation so that simply because we just want to keep everything sandboxed and just ensure all of the output does not interfere with the core VS Code. So we try to, in the iframe, we try to add placeholders to ensure that there's some white space or empty space for the cells. So that's how we adjust and move things. And then we have placeholders for output. And as you display or as you scroll into the output, that's when we render the output component. Hope that makes sense.
So you have one iframe that holds the complete state of the notebook, basically. And then you have iframes that display the.
No, it's just one iframe. Well, a single iframe that displays all of the output in one view.
Interesting. So then you have to somehow manage the spacing to display everything properly, right?
That is correct. So there is a lot of work has gone into that one, and
I can imagine.
So for now, it seems to work well. We found that it's initially there was a lot of work. There were, I would say, quite a lot of bugs that we had to address in terms of scrolling, auto sizing. But after that, now that we've looked into all of those and addressed it, it seems to work pretty well.
Interesting.
And we went down to the path of one iframe because we have one widget manager. So we didn't want to. We also did, I think, at one point look at having multiple iframes, but then that would mean we would have to have, each iframe with its own widget manager. Then we'd have to send all of these, deal with the synchronization of kernel messages across all kernels. Right now, we only need to synchronize between two kernels. One is at the UI and one is the backend. And as mentioned, that was the most complicated piece in implementing IPy widgets. So we don't want to have too many of those.
Right. Dom, can I ask about what exactly the two kernels are trying to keep in sync? I'm a little bit confused because usually we're talking about kernel. I'm thinking about IPython kernel, but what exactly are those? What exactly those two kernels are, and what states they're trying to keep in sync?
So it is the iKernel connection. So it's the kernel interface. So there is a kernel interface over here. I think I can bring this up. Let me see this. Here we go. So so it's basically an object with some methods on it to send and receive, to basically communicate with the real backend kernel. So when I say trying to keep that in sync, for instance, if the user executes a cell on the notebook, a method called request execute is called. And then that would fire an event, IOPub message is fired. That's triggered.
Yep.
What we do is we replicate those same messages at the other end as well, at the UI end. So if I were to go back to this, execution happens on the remote side or the extension side, because that's where, so we execute that. It goes to the WebSocket, to the real kernel, not the WebSocket, sorry. But IOPub messages are fired at that end. So what we try to do is we mimic or we replicate all of those same messages on the UI side as well. So if you if you get responses, we have the same things coming through at this end. So all we do is we take the messages that are going, that's being sent and received in the WebSocket layer, and we replay those same things at the other end. So the WebSocket in the UI side also sees the same messages that's being sent and received. And so, yeah, that's what we do. So we found that that was required for output messages and some of the more complex third-party widgets that are dealing with COM messages. So they listen to IOPub messages. They have custom COM messages and hooks. So we just figured, rather than dealing with specific messages, it was just easier to replicate or basically keep all of the messages in sync. So it's not maintaining state, it's just the messages. So that's all we're doing. If we get a message, if there is an on IOPub message, we send that through to the other side. But we do it at a much lower level. We don't deal with individual messages. We just deal with the WebSocket messages. As we get messages from ZMQ, we see there's a message. So we pump that through the WebSocket layer. So all we do is we take that one and send it to the UI side as well, so that both the kernels or both the iKernel connections get the exact same stream of messages.
Gotcha. Thanks for explaining. And that syncing is bidirectional, right?
That is correct. Yes.
Okay.
So that one is, well, simply because of third-party widgets. Third-party widgets can execute code, they can create COM messages, they can register hooks. So we found that, like, initially we figured that we didn't need to have to support everything, but then every now and then you test a couple of widgets, you'll find some widgets have the ability to execute code and do all sorts of other things. So that's why we just went down the path of just synchronize at the lowest layer possible. And then the widget manager just works.
So just to follow up question there. So if the diagram is correct, you don't have a widget manager on the extension side. So you don't have any COM targets there. So you don't have to deal with it.
That's correct.
Two COM targets. So that should at least make it simpler, right? Yeah.
That's right.
Is a helpful mental model that both of these Jupyter Lab kernels are connected directly to the actual kernel? That's sort of, is that what you're trying to get both kernels to think, that they're both connected directly to the Jupyter kernel?
Yes, that is correct. So on the UI side, we need that so that the widgets work and we don't have to deal with anything, because we've effectively given it a real kernel, and from there on we just assume that things will work and we don't need to do anything special. And on the right hand side, the extension host, we have a kernel which is the iKernel connection. We use that interface to communicate with the real kernel. So the VS Code uses that one. So that is our API layer. So if ever we want to run any user code, for instance, we've got different components like for debugging or getting a list of all the variables, trying to run user code, I can't remember what else. So that's where we use that interface.
And a quick question.
We only use one or two of them. I think it's primarily request execute and request complete. Those are the two ones, and maybe I think request kernel info as well. Those are some of the most important ones that we use in the extension side for most of what we need.
And a quick question on the notebook side. My understanding is the notebook was sort of a very generic component in VS Code. Is that your team as well working on that? Or
Yes.
Oh, okay.
Yes, it is generic. So, yep, that's correct. Yeah. So
One question about the. Oh, sorry.
I just want to add something about the notebook. So there are two parts to it. One is the user interface, and the other one is the execution. So it is generic in the sense it is not specific to Jupyter. So the user interface is, we've got a couple of cells, you've got output, that's basically it. You've got some kind of a language that's associated with the individual cell. And then you've got this thing called a kernel picker, or we call it controllers in VS Code. You can select something. So unlike in Jupyter, what you have is you have a kernel spec. When you select a list of, you select a kernel, you're actually selecting a specification saying, create an active kernel based on this specification. Whereas in VS Code, it's slightly different. This is an actual object that is going to run the code for you. Whereas in Jupyter, you have to instantiate the kernel. So if you were to pick something over here, this is actually a pretty bad example. I should open a different kind of a notebook. You could think of this as, so I've got a PyEnv controller in VS Code. So that's the terminology we use. And that has a method called execute. So if you were to select that and you to hit run, what happens is there is a class that is associated with that, an instance, then the execute method of that one gets invoked. Whereas in Jupyter, if you select something, we create a new instance of that one. So other notebooks that were to select the exact same thing, they end up creating a new kernel yet again. Whereas in VS Code, they would share the same thing.
So is a helpful abstraction that you're essentially picking an iKernel connection, and that's an abstraction on how to communicate with the kernel, and it may not even talk to a kernel. It may do something different.
That is correct. Yes. So in Jupyter, in VS Code, it is not. It's not specific to Jupyter except for the Jupyter extension. So that's where we try to bring stuff that's very specific to Jupyter. Whereas in core VS Code, the notebook UI is just a generic UI. And in terms of execution, it's just a very generic execution model, not specific to Jupyter notebooks or anything else.
One question about the iframe. So we heard that's the magical part. So I assume the layout is like, from a DOM perspective, it's two iframes on the same level, but they are displayed on top of each other, and they're interspaced so that the one actually shows the cells and the other shows the output. Is this correct?
Yes. So yes, but I wouldn't think of this as an iframe. So because all of this that you see is one single DOM view. So if you were to inspect this, you would actually see this is all within the same DOM.
Okay, so only the iframe for the custom, for the widget output is laid on top of the notebook part of the user interface then?
Yes, and I believe it is under the cells. If I'm not mistaken, it is behind rather than laying it on top.
All right, and for the...
Yep.
No, sir?
No, go ahead.
And for the kernels, so is this type like really linear? So every message from the iframe will go to the kernel in the extension, and all those will go to the like backend, I call it now, or is it more like a triangular thing where like do all of the messages like from the left always pass through the proxy WebSocket in the middle?
Yes.
Okay, cool. Thank you for sharing.
Any last questions for Don?
I'll just throw out like just you mentioned that the single iframe was that was primarily because of widgets, or like was widgets just sort of benefited from that?
I would say widgets benefited from that. So this has gone through a couple of iterations, the notebook UI. Initially, we started with a React-based notebook where we had all the cells and the output in the same iframe or the same WebView component. And then we pulled all of this into VS Code. And in order to gain the benefits of VS Code, since they already have editors, for instance, if you open a package.json file, there is an editor component. So we didn't want to take all of that and cram it into a separate web view. We wanted to reuse that same infrastructure, existing code. All we needed was having multiple editors in a single view. Whereas over here, you're dealing with one editor. Everything is just a single editor. Whereas with notebooks, you can have multiple text editors. So that was one. And the other one was, or the other difference was we had to have the concept of output. So that's where we felt that rather than trying to take editors and plug it into an iframe, then things don't really work too well because of extensibility. Because today, if anyone wanted to create a VS Code extension, they could hook into these text editors and write all sorts of extensions. But the moment you put it into an iframe, there is yet another boundary that needs to be taken into consideration.
All right. Well, thank you very much, Don. Thanks for everyone coming, and thank you again, Don, for sharing this with us. It's fascinating. Thank you.
Thank you.
Thank you.
Yeah, that second order estimator